All right, so let's go ahead and move on to problem 2. Gaussians are fun. It's debatable, but anyways, so we have a population, normally distributed population mean of 298, standard deviation of this. What is the probability of measuring a voltage? Ooh, should not be voltage. Temperature. Temperature less than 300 K. So we're going to pull up our PDF. We have our Z function. So again, it'd be helpful if we draw this as well. So 298, so 300K is going to be around here. So it's going to be this. So that better be greater than 0.5. So let's go ahead and do our Z function is going to be equal to 3. Our X is 300, our mu is 298, and our standard deviation is 1.3. And let's integrate our PDF. PDF from a Z value of basically minus infinity, because we're doing less than, minus infinity, infinity to Z. Squiggly close. It's thinking. And there we go. So it's about 93%. So from minus infinity to that Z function. Fantastic. Calculate an interval which contains 21% of the data. So now what we have to do is we're going to go ahead and say solve. When does the integrate from minus x to x, when does this equal 0.21? And that'll give me a Z function. So now I'm going to say solve Z function and solve for x from 298 to 1.3. Solve when this equals plus and minus this Z value to give us 21%. So 298.344, very tight. And then minus, that will contain 21% of my data. Fantastic. What's the probability of measuring a value between this and this, and then greater than 297? So let's go ahead. We can take this. Let's do this. So in between 299 and 302. So let's go ahead and the lower value will be 299. We're still on the right side, so this should be less than half, 302. And there we go. What about greater than 297? So we can take this. I should just move the Z function over. So we're doing greater than. So this is going to be 297. This better be greater than 0.5. Infinity. Yep, great. Would a measurement of 305K be an outlier? What about 296? So remember, if we do 298 plus 3 times 1.3, so if it's greater than this, the 301.9, or if it's less than this, then it's an outlier. So 305 for sure is an outlier, and 286 is also an outlier. So they're both outliers. And what's the probability of measuring a value of 290K? Can't answer that question. We want the bounds. So we don't deal with, in this class particularly, the probability of measuring a single basically value or a single measurement. So that is it. We will see you for the next problem. Thanks. Bye.